Hi, it's Terry Dennery of the MathWorks. So in this video, we're going to move a little bit more toward flight controls. And controls begin with figuring out what you actually want to happen, and we generally pack all of that into a command signal. So think of this video as really kind of the creation of the command signal for each of the individual propeller motors. We'll get quite a bit of it into it in this video. So, anyways. Yeah, so we got kind of this relationship between propeller speeds and thrust, and in this video we'll kind of figure out what those speeds need to be to get the thrust and how we're going to do that with a controller. So let's open up a new model file. I think I'll move this like right there, and kind of begins with, well, what do you want to do is really its trajectory, all right? And so I'm going to use these blocks that have served me very well over the years, right? So these motion, let's see, mechanical components, motion signals. All right, so let's get a smooth step position, right? And we're going to define the altitude versus time, right? So think of this as the quadcopter is going to take off vertically and it's going to just go straight up, right? And so it's really a vertical trajectory, right? And so we're going to have it start going up at 10 seconds. We're going to take 100 seconds for it to go from 0 to 2,000 meters. All right. And we want to begin by figuring out what is the thrust required to do this. Right. And so, yeah, F is equal to MA. So we're going to pick off that A. So we'll recall trajectory with these blocks is defined in terms of PVA, position, velocity, and acceleration. Right. So let's get a selector block. Okay, and the acceleration will be the third component. So I type in a 3, and we're picking that off. Now, it's really a combination, though, of the acceleration as well as the gravity that you're overcoming. And so we need to include gravity as well. So we'll use a constant block for that. And let me go back to MATLAB, clear commands as well as clear workspace. Right, and we saw this script in the previous one of the previous videos, but in addition to bringing in propeller properties, I went ahead and defined my gravity constant there. So we'll use that. And then when we brought in the mechanics from SimWise, we also created a data structure. That's part of the script. Get Geometry did this for us. Right, and you'll see that my assemblies are going to gather all the masses of all the parts that make up that assembly, and there's that number that's pretty close to 20,000 kilograms. All right, so let's use that. Let's first get the gravity constant. Okay, and this will be a simple addition. Okay, and we need to multiply that. It's again F is equal to mass times acceleration. So we'll multiply this by an M. Right, so assemblies dot. Did I misspell it? Do I got assemblies in there? I do. Okay, so let me make sure I get this right. There it is. Okay. All right, and so now I'll get a product. Okay, so that's a pretty good thrust calculation. And so I'm going to pack that into here. And I think I'll call it thrust estimate this time. Not be so sure of myself. Okay, all right, because there can be other things that might affect it. Okay, anyways, let's put this in. I'm going to call it trajectory underscore PVA, and then this will be thrust. All right, I'll put that in its newtons. Okay, and so, that's an important calculation, but we're not done. That we really need to figure out how to implement that through the rotational speed of the propellers. So we got a little bit more work to do. And it turns out that the blocks that we created a little bit earlier for figuring out thrust are useful for us. And so I'm going to copy one of these and just pop it in right here. And I will call this now prop operation. Seems like a decent enough name. What I really like about this is that I already have kind of the two key parameters are already loaded into the block, right? And so as we go in here now, it's just also just kind of follow again the formulation, and we'll use that, right? But our basic goal is to take thrust in. Let's rename this input thrust, all right? And to calculate out prop speed, rads per second, okay, and prop load. That'll be Newton meters. Okay. All right. So anyways, it'll begin by taking that thrust and dividing it by the lift coefficient. Okay. And so you'll recall that it's a speed square law. And so there's a little bit more to do here. And so I'm going to go get a square. Oops. There, square root. And with that, I got speed. And the load's pretty easy to do, just like we did it before. Take thrust and divide it by L over D and multiply by -1. All right, so and that looks pretty good. All right, and the last thing to do to really kind of set up my command signal, I believe, is to because we'll probably want to apply feedback on vertical position. So let's get that vertical position from our command as well, and that's going to be the first component. All right. And with that, I think I kind of got everything I need with regard to setting commands on for my controls. Right. So let's put that into a subsystem. And we'll name this one Z parentheses M for meters. All right. And so in the next video, we'll use this and begin to kind of come up with our approach for controlling those motors to get the right thrust per each propeller. All right, very good. Thank you.